Hello everyone, I'm Qing, Technical Support Engineer of Asia and Oceania Center. Today I'm going to have a presentation about SuperMap Boost Smart Transportation. The presentation will be introduced from the following four aspects. The first one is about how to construct basic transportation GIS application system. The next, we are going to learn about how to further construct a more complete system of transportation business. We call it Transportation One-Man Platform. Then, because of the 3D technology development, we will talk about why transportation construction needs 3D technology and what 3D technology can do in transportation construction. At last, with the development of big data, we are going to talk about how to integrate transportation construction with big data technology. So let's take a look at the first part, how to construct a basic transportation GIS system. Here is the basic transportation GIS system construction. First of all this system cannot be constructed without hardware equipment and software. And the second and most important layer is data management. Data is the soul of GIS. There are various data related with transportation, including spatial data and non-spatial data. All this data need to be processed, classified, and stored based on a certain data standard. Different types of data need different storage. The next is what kinds of services need to be used for developing applications. It is based on the requirements of the system. The basic applications, maybe you want to realize road network management, traffic facilities management, or statistics of various data, route design, navigation, and so on. We may need these services for these functions, map surveys, data surveys, and some analysis services such as network analysis services, spatial query services. The last layer is user layer. We need to know which terminals should be used, who will use this system, and all these modules form a complete system. Next, we will mainly talk about the data management of transportation GIS platform and how to realize applications through services. Firstly, let's look at how to integrate multi-source data in a system. We can integrate the spatial geographic data in a map by thematic map. Data for each category can be displayed on a map as a layer. Each layer can be controlled through layer management and scale. Besides, facilities information is usually saved in the form of documents. GIS can realize visual management of facilities after synchronization and associate the attributes with the spatial information of facilities. Users can easily query status and the information of various facilities on the map and clearly understand the spatial distribution of them. GIS also can realize spatial query and attribute query of all the spatial elements. The platform supports the input of keyword query and also supports the click of query element details on the map. The system can also provide the spatial statistical function of traffic thematic data and display it on the map in the form of thematic chart, such as road length statistics, construction fund statistics, maintenance cost statistics, and so on. Network analysis is a basic analysis in GIS, which can realize path design of two locations and list all routes available. It can be the shortest route or the route costs least time. At the same time, with the mobile application development, route navigation between 2 points can be realized. For the problems found in the process of petrol inspection, professionals can input the detailed information, location, level, and other information of the problems through the mobile terminal for reporting. At the same time, the reported issues are stored in a specialized database, which can be displayed and managed in the platform. The issues maintenance status can be checked on the map. The red icons represent issues that have been submitted but not fixed, and the yellow icons means the issues are being solved, and the green icons indicates that the problems have been solved and passed to the acceptance. Besides, users can also check the details of every event. For emergencies, GPS is used to locate the incident. Users can quickly fill in the information, access to multimedia means such as photographing, hand drawing, audio, and so on, clearly displays the site status so as to realize real-time report based on mobile network. The next, we are going to further learn about how to construct a more complete system of transportation business, one-man platform of transportation. Firstly, let's have a look why the system needs to be improved. There are so many other businesses applications need to be integrated in the system, such as railway business, aviation business, travel service, ports, logistics, are all involved in the transportation, and each of them has their own business requirements. So how to assist the industry to share and integrate spatial geographic information resources, and how to integrate the various business applications into one system, and how to save the construction costs of industry spatial data management, improve the quality of data service and user experience. This all need to be solved in our one map platform. Then let's also see what are the challenges of transportation GIS. Firstly, with more and more GIS data generated, how to manage, store, and update the increasing information. And there is also a large number of repeated and decentralized spatial information, how to optimize it. In addition, there is a lack of unified standards for the management of space information and a lack of space information sharing mechanisms and technical means. The last one is that with the development of internet electronic map, how to construct a system that's more professional, more reliable, and even more practical applications. With these questions, here we propose the IKW model to solve deepening industry application. It is a development mode from data to wisdom. In the traditional way, we always solve problems according to the data we have. So we can only do a few applications around the data. But if we further integrate the data, extract the valuable information, we can do much more applications. And the future development direction is to solve the deeper industry problems in a more intelligent way. With the new development modes, we propose Transportation One Map, which can integrate transportation industry spatial resource, provide application foundation of traffic spatial information, and be a platform of spatial information sharing within the transportation industries. This picture shows how to organize information spatial splicing based on one map. The first level is City Department of Transport, which provides local transport thematic data, road network, railway network, and the second level is Province Department, which in aggregate provincial traffic semantic data, and the last level is national departments, which aggregates national traffic semantic data. So the main ideas of transportation one map can be understood like this. The business information integration of each region can be spliced in space to achieve a complete picture. This vertical business integration and horizontal regional splicing spatial information framework is called one map. The steps to realize one map integration are data collection, information integration, service sharing, and finally realize intelligent management through cloud technology. Based on the above ideas, we have developed the open framework product of one map and formulated the standard system. Traditional mode is to develop a specific business for a requirement. This new platform integrates multiple industries into one system through a unified GIS management platform. With it effectively improve resource utilization and sharing. Then let's look at what the platform should be built. The content includes three aspects: standard construction, data construction, and system construction. Let's firstly have a look how to realize standard construction. There are three parts. Management specification, data specification, and service specification. The core construction is data specification. This part may discuss how to standardize different types of data. And then the data classification system is divided into information, service, graphic mode, and interface. And their respective specifications are established to generate service sharing specifications. Besides, the management specification can be established by creating data document specification and data backup specification so as to achieve one map standard system construction. And the core content is how to convert data to service. Each industry data has its set of data. We provide classified storage based on the data standard. Each industry data can be divided into general spatial data and industry private spatial data. And general spatial data can be integrated to one general spatial data and one traffic public spatial data. Finally, there are three types of database composed transportation geographic information data platform. General spatial data, which store basic geographic data, and traffic public spatial data, which stores traffic semantic data, and all the industry private spatial data. The next step is to realize the construction of transportation service platform after data classification. Firstly, we need to know the user layer, who will use these services and what they want to do with these services. Like the business departments, they may want to provide comprehensive functional services, integrate the application system, and also develop framework SDK. The decision-making departments want to realize spatial presentation of data mining and the spatial statistic analysis of traffic. And the public may want to know the detailed and accurate travel services, as well as real-time traffic information. So therefore, we first need to publish static data as GIS general service to provide the basic functional services. The dynamic data is published as data publishing services, providing real-time services. We also need to publish data mining results as professional transportation services, which provides statistical services and analysis services. Finally, mutual support is realized through shared service platform. So data management and service management, one map system is built to realize the application to users and generate standard application service at the same time. And each level is based on its corresponding standards. Finally, the platform will form three types of services applications: map service, data service, functional service. This application can be obtained by accessing the platform, and each service corresponds its functions to meet the requirements of different users. Here, let's have a look at a case of one map application. This is one map platform of Jiangsu province transportation. The homepage integrates with data sharing module, service management module, public information publishing module, and provides application interfaces of resource center, development center, map center, and application center. All business applications are integrated into the application center, including road application, railway application, airport application, public traffic application, port application. The second case is the Traffic Emergency Command Platform of Xinjiang. This system not only integrates information sharing and applications, but also provides emergency reporting and handling, as well as command and dispatching. So the transportation one map is already a complete platform. The next we are going to talk about how to optimize transportation construction with 3D technology. Firstly, why we need 3D technology? At present, many 3D entities have been formed in the main roads, bridges, tunnels, and culverts. Especially the main connecting lines and roads around the city are all mostly complex overpasses. And we lack effective 3D display means traditional maintenance is mostly based on the management and application of 2D vector data, lacking the ability to restore the terrain around the road to 3D scene and cooperate with emergency rescue to develop an overall solution. So we need 3D technology to display the 3D entities and make an overall solution with 3D analysis. So let's look at how 3D GIS assists for transportation construction. Firstly, 3D GIS provides better visualization of the reality scene. We can view the sky, the objects on the ground, even objects underground at the same time. It also can solve practical problems such as the height design of overpass and display interior space such as the tunnel model. Meanwhile, 3D technology makes the intelligent scene as possible. You may wonder what kinds of 3D models are supported. Here list some main 3D models like oblique photography model, beam, point cloud, and 3D terrain fan model are all supported to integrate with GIS. The way to match multi-source 3D data is converting 3D model to a format that GIS is accessible. The model integrity attributes and the consistency between graphic and the model need to be ensured after the viewing. Each model is added to this scene as a layer. Here, let's see some cases of the 3D model viewing. The first one is the integration of 2D vector line with oblique photography by 3D symbolization. Here we can see how to integrate the 2D data with the oblique photography and how to symbolize the 2D line to a 3D symbol. So here we finish to symbolize the 2D line. And also, this is the integration of 3D model of professional modeling software and GIS. And this video shows the integration of BIM with oblique photography, 3D terrain image, and other geographic data. The status of the viaduct under construction and the work site, as well as the terrain around it, is vividly displayed. 3D GIS also provides many analysis functions. The first operation is 3D spatial expression, which not only displays the realistic object, but also the shadow body, visible body, and skyline. The second aspect is 3D functional operation, which including spatial operation and spatial relation judging, spatial analysis, also the 3D measurement. Also 3D data can be converted to 2D and also can realize the 3D print as well as volume computing. Also customized development is also supported with WebGL. Here are the results of 3D analysis, 3D slope and aspect analysis, profile analysis, 3D isoline analysis, and 3D buffer analysis. The minimal vertical clearance often need to be sure in the design stage. The 3D model will display and measure this value. The tunnel body model is built by convex hull, and the spatial operation between convex hull and the mounting body is realized to dig the tunnel. 3D analysis can realize some 3D spatial relationship queries and judge the relationship between two spatial entities, including contain, disjoint, overlap, and intersection. The example shows the intersection results of subway and building. The buildings that intersect with the subway are highlight display. In the practical application, integrated 2D and 3D technology, the system can display 2D and 3D integration scene. We view the overall status with 2D view. Meanwhile, display core construction scenes with 3D model. Monitors the construction status. And also check the risk sources. Query and highlight the risk sources. Meanwhile, in the mobile terminal, it can realize 2D and 3D integrated visualization and 2D and 3D integrated navigation, as well as indoor and outdoor integrated navigation. Finally, let's take a look at the application of big data in traffic development. First of all, we need to briefly know what constitutes the big data GIS technology system. Cross-platform GIS and cloud GIS is the basic technology of big data GIS. The core technology of SuperMap big data is big data storage management, big data distributed analysis, and stream data, big data visualization. We already know that the diversity of traffic data sources, but how to store and the growing amount of basic graphic data and semantic data, and how to highly efficient display them. SuperMap provides distributed SDX, which includes the HBase distributed engine, MongoDB, also the HDFS distributed file engine to store the big data. Let's take a look at the result of amount of 450 million line data based on HBase storage. It is displayed smoothly in this system. And big data analysis operators based on SuperMap and Spark are growing. SuperMap provides different analysis operators for 4 different types of data. Based on these analysis operators, the results of big data analysis can be displayed in a deeper level. Like OD analysis, the principle of OD analysis is to mine and analyze the starting and ending points of traffic and the connection degree between stations from big data. This video shows the comparison of morning and evening peak flow between 2 subway stations of Beijing. It is planned to build a road across the whole area, and all influence land parcels need to be found out. This example shows the display of large number of land parcels with 10 distributed clusters. Then do buffer analysis and overlay analysis to calculate the occupied land parcels, which only takes less than 45 seconds. Integrated with IoT technology, big data GIS can realize real-time monitoring through streaming data service and distributed service, as well as big data analysis. In this example, real-time query of road conditions is realized based on distributed storage and big data analysis by accessing real-time traffic flow data. And this video shows the statistics of taxis get-off points in the evening rush hour based on big data hotspots analysis. Based on the taxi data, analyze the contact degree of each district and county where are population input errors and where are population outflow errors. This video shows the number of global airplanes in a certain period of time based on big data aggregation analysis. Here, that's all for my presentation. Thank you for your listening.